So this is the week 6 lecture video for Math 203. In this video we'll talk about the metric system, other systems of measurements and converting units, and we will talk about temperature and time. So first thing we're going to look at is the metric system. Metric system is a decimal-based system of measure. So our three basic units of measurement. Meter measures length. In our U.S. system, we measure length in inches, feet, yards, miles, and you have to convert between all of them. Well, with a meter, the measurement is decimal based, so it's all powers of 10 based on the meter. The gram is your weight measure. Here in the U.S., we use pounds, ounces, tons. In the metric system, it's all based on variations of the gram. And with volume, we have many different volume measurements when we measure liquids. In the metric system, it's all based on powers of 10 of the liter. So length, we measure in meters. The abbreviation is M. Weight or mass, we measure in grams. The abbreviation is G or GM, but normally just G. Volume is the liter, and notice liter is a capital L. So with the metric system, you have your base measure, either the meter, the gram, or the liter. And then you have powers of 10 of those base measures. The kilo is a prefix. This prefix can be applied to any measurement, any of the length, mass, or volume measurements. So kilo is 1,000 of each of the base measurements. So if you're talking about meters, kilometer is 1,000 meters. Gram, kilogram is 1,000 grams. Liter, kiloliter is 1,000 liters. And centi is actually 100th of each of your base measures. Milli is 1,000th of each of your base measurements. And micro is 1,000,000th of each of your base measurements. So if you think about it in terms of equivalencies, a kilometer equals 1,000 meters. Then your meter is your base measure. The centimeter is equal to 1 100th. So a centimeter is 1/100th of a meter. Then a millimeter is 1/1000th of a meter. Micrometer is 1/1,000,000th, 10th, 100,000, 100,000, 1/1,000,000th of a meter. So you can either remember the equivalencies, or what I like to do is I use what I call my metric number line. So here you can, it's kind of like a visual aid. Let me put this on. Hold on one second. So I'm going to paste this onto my notebook, and we'll see how I use it. So see, you have your kilo, your milli, and your micro. Now these two measures in here between the base unit and the milli are only used in the medical field when we deal with length, so we'll go over those in a minute. So for any of your measures, whether it be meter, gram, or liter, if you go from kilo to the base measure, you're multiplying by 1,000. 1 kilo is 1,000 of the base measures, which I have noted here. Every time you go from a kilo to a base to a milli, or a milli to a micro, you're multiplying by 1,000. Multiplying by 1,000 is the same thing as moving your decimals to the right 3 places. So if I had, say, 45 kilograms, how many grams is that? Well, I can multiply by 1,000, or think of it as moving your decimal place 3 places to the right. So it would be 1, 2, 3, 45,000 grams. If you have 10 milliliters, I want to know how many liters that is. I'm going to be dividing by 1,000. Milli to the base unit would be a division by 1,000, or move your decimal place to the left 3 places. So it would be 1, 2, 3, so I had 0.010 liters. So you can either think of it as multiplying by 1,000 when you're going to the right, or moving your decimal place to the right 3 places, dividing by 1,000 when you're going to the left, or moving your decimal place 3 places left. So that's kind of a visual that can help you with quick conversions within the metric system. So if you're going from micro, so say you have a microgram, you want to know how many grams that is, you're just going to go back 3 6 places. If you have a kilogram and you want to know how many milligrams that is, you're going to go to the right 3 6 places. So you would basically count your decimals or multiply by 1,000. To go from kilo to base, you're multiplying by 1,000. Base to milli, you're multiplying by another 1,000. So kilo to milli, that's not 2,000. It's 1,000 times 1,000. So that's 6 zeros, which would be a million. Kilo to micro would be 9 zeros, a billion. Okay, so a few notes about metric system. We use decimals, not fractions. We always write that leading 0. If your quantity is less than 1, then there's nothing before the decimal place. In the medical field, we always want to put a 0 there. That's a safety measure, just in case so you don't miss the decimal. Because if you didn't write the 0 there and you missed the decimal, you might be administering 750 milliliters when you're only supposed to administer 0.75 milliliters. So always use that 0 in front of the decimal. All your prefixes, milligram, milli, centi, micro, everything is lowercase except the L for liter. Liter is the only uppercase letter because the L looks too much like a 1. We write the number first, we leave a little space, and then you write your unit. We don't write the unit in front, and we don't put them right together. Okay, so here is the middle two divisions between base unit and milli when we're talking about length. Now, we don't really use these when we're talking about grams or liters, but centi we use when we're measuring length. We use the centimeter. So your base unit here would be the meter. So just like the line before it, here I'll put them together 1 second. So here's the original line. And within, between the base and milli, you see we have these two additional divisions. Those are represent so it's like we just took this piece and blew it up. So these little lines here, that's deci and centi, which we usually just use centimeter. So note, we know from the base to milli, that's times 1,000, or 3 decimal places. The reason that is 3 decimal places because each of these is 1 decimal place. So if you're going from the base unit to centi, you're going 2 decimal places. 2 decimal places is 100. So 1 meter equals 100 centimeters. So if you're going from meter to centimeter, you're multiplying by 100 or moving the decimal 2 places to the left. If you're going from centimeter back to meter, that's again 2 places to the left, so you're going to divide by 100 or move 2 places to the left. So then notice between centi and milli, this little piece right here, there's only 1 decimal place. So that's 10. From centi to meter, you multiply by 10 or move 1 decimal place. From milli to centi, you would divide by 10 or go to the left 1 decimal place. So 1 centimeter equals 10 millimeters. 1 millimeter equals 1/10 of a centimeter. So conversions within the metric system, I think, are pretty easy. You're just hopping back and forth on a number line. Just remember which places are thousands and which places are tens. So most of it's going to be thousands. Kilo to base. And remember, your base unit is either gram, meter, or liter. So a kilogram to a gram would be 1,000. Gram to milligram, 1,000. Milligram to microgram, 1,000. But this centi comes right in here, deci and centi, but we only use centi. So gram to centigram or meter to centimeter would be times 100, centimeter to millimeter times 10. So you can also use, I think the number line is kind of the easiest way to do it, because you can just visualize it or just draw the number line and count back and forth. But you can also use your dimensional analysis method of conversion. Dimensional analysis works pretty well, I think, in other settings. I don't really use it for the metric conversion, but you can. All you have to remember is your equivalencies. So we know that 1 gram, if you look back at the number line, 1 gram would equal, you multiply by 1,000 and multiply by milligrams. Okay, so from gram to milligram, you would multiply by 1,000. So 1 gram equals 1,000 milligrams, which is stated right here. 1 gram is 1,000 milligrams. So you can write that as a ratio. 1 gram is to, there's 1 gram to every 1,000 milligrams, or you can even write it upside down to state there's 1,000 milligrams to 1 gram. So you can use the ratio either way, depending on what you're converting from and what you're converting to. If you're converting from grams to milligrams, So 1 gram equals 1,000 milligrams. So if we have 2.2 grams, and we want to know that equals how many milligrams, you can take your 2.2 grams and multiply by the equivalency. And now remember, we want to end up with milligrams, so we're going to write the ratio with milligrams on top and grams on the bottom. We do that because when you multiply fractions, you can cancel the g. Remember, any number you can place over 1 to turn it into a fraction. So you cross cancel the g's. 2.2 times 1,000 is 2,200. Now, if you were converting from milligrams to grams, so say we had 0.25 milligrams, and we want to know that equals how many grams. Now you would take your milligram and multiply it by the equivalency, but you want it upside down now because you want to get rid of the milligram unit. So when they're on opposite sides of the fraction bar, you can cancel them. So then 0.25, if you multiply across the top, you get 0.25 grams over 1,000. Remember, fraction is division, so you're taking 0.25 dividing by 1,000. So that's going to give you 1, 2, 3. So 1, 2, 3, 2, 5. I'll do it down here. 0.12325 grams. Okay, so that's pretty much how dimensional analysis works. Your equivalency is going to be written as a ratio, and you're going to multiply it by what you have. But you have to decide which unit goes on the top, which unit goes on the bottom. The one you're getting rid of goes on the bottom when you write it as your equivalency ratio. Okay. Then you also have your proportion method. So the proportion method works well. I tend not to use that. I stick with the number line or dimensional analysis. But basically with the proportion, you just have to remember how a proportion works. A proportion is two ratios set equal. And your cross products must be equal. So if we have 132 grams and we want to convert it to milligrams, well, we know now with the ratio you have to keep your units consistent. So if you have grams on top on the left side, you have to have grams on top on the right side. So we know 1 gram equals 1,000 milligrams. So we want an equivalent fraction, basically is what we're saying. That's what our proportion helps us do, set up an equivalent fraction. I know 1 gram is to 1,000 milligrams, so 132 grams is to how many milligrams? So if you cross multiply your 132 times 1,000, that's 132,000. Then you divide by the only number left, which is 1, and that is your solution, 132,000 milligrams. So if 1 gram is 1,000 milligrams, 132 grams is 132,000 milligrams. Say we have 0.028 kilograms, and we want to convert that to micrograms. set up a proportion. 0.028 kilograms is to how many micrograms? And we know 1 kilogram equals, and if you don't remember it right away, look back at your line. Here's kilo, and here's micro. So that's 3, 6, 9 zeros. So a 1 with 9 zeros on the back of it. So 1 kilogram is a 1 with 9 zeros, or a billion micrograms. So when you cross multiply the 0.028 times the billion, 0.028 times a billion. Be careful with zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's very easy to miss a zero or add too many zeros. So when you cross multiply, we're going to have what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oop. Why am I writing G? 9. So that would be 1, 2, 3 places, 4, 5, 6, 7, 8, 9. So that's 28 million micrograms. So 0.028 kilograms equals 28 million micrograms. And here's another example here. 2.46 grams is how many milligrams. So you set up your proportion, multiply 2.46 times 1,000, 1 times x. Then to find out what x is, you divide by the number in front of x. So we would divide both sides by 1, and we get x equals 2,460. So 2.46 grams is 2,460 milligrams. Okay, and here is some practice. So 23 grams, how many kilograms? So if I'm at gram and I want to go back to kilogram, that's 3 places, right? 3 places to the left. So that would be 0.023. Put this over here. So 23 grams would be 0.23 kilograms. Now 8 kilograms. If we're going from kilogram to gram, we're going to go 3 decimals, either multiply by 1,000 or 3 decimal places to the right. So 8 kilograms equals 8,000 grams. Okay. Okay, so the next thing we want to look at, chapter 5. With the answers to the rest of these, if you look at the slides, you'll see notes on the bottom, and you'll have the answers, so you can go ahead and practice those. Or you can practice in your book. So, chapter 5, other systems of measure, and chapter 6, converting units. So, with all these conversions, there's no nice visual number line to use. So, you have to memorize your equivalencies. 1 teaspoon is 5 milliliters, a tablespoon is 15 milliliters, an ounce is 30 milliliters. So, this is something that it's good to make flashcards with. A lot of you already know a lot of these, which you probably use them every day. So So there's no nice, neat number line for these. You have to memorize your equivalencies, and you have to either use dimensional analysis or proportion. Or there's a way I use, I'll explain it in a minute. So, teaspoons and milliliters. If we're converting teaspoons, say I have 4 teaspoons, and I want to know how many milliliters that is. Dimensional analysis, we have 4 teaspoons, and we're going to multiply by our ratio. So we want to know milliliters, so we want that on top. So we know 1 teaspoon is 5 milliliters. So here we can cross out our T's. 4 times 5 is 20 milliliters. Proportion method. 4 teaspoon is to how many milliliters when we know 1 teaspoon is 5 milliliters. 4 times 5 is 20. Divide by 1. So we know 4 teaspoons is 20 milliliters. So another way, it's not really in your book or anything, it's just the way I memorize these. With my equivalencies, I always memorize ones on the left. So here they have 15 grains equals 1 gram. I would flip this around. I would memorize it as 1 gram equals 15 grains. This way, if you memorize the ones on the left, whenever you're going from the left unit to the right unit, you're going to multiply by this number in front of the right unit. If you're going from the right unit to the left unit, you're going to divide by this number. So 1 pound is 454 grams. We'll look at that. Or, sorry. Yeah. 1 pound equals 454 grams. Okay, so if I memorize this, I know 1 pound equals 454 grams. So however many pounds I have, say I have 32.5 pounds, I'm going to take that 32.5, multiply by 454, and that'll give me my number of grams. 32.5 times 454, 14,755. But if I'm going from grams to pounds, say I have 1,256 grams, and I want to know how many pounds that is. Well, since I know 1 pound is 454 grams, 1 gram is going to be the division. Think about it as dividing. So to find the grams, I would have to divide by 454, and that'll give me pounds. So if I take 1,256, divide by 454, that's roughly 2.3 pounds. We'll round it. So we'll say 2.3 pounds. So if you always memorize the ones on the left, and we'll call this the L unit, and we'll call this the R unit. So if you memorize your ones on the left, anytime you're going from the L unit to the R unit, you would multiply by whatever's in front of the R. If you're going from the R unit to the L unit, you would divide by the number in front of R. That's just the way I do it. But your proportion method and your dimensional analysis still work. You have to memorize your equivalencies. So, grams and grains. We know 1 gram is 15 grains. So 8 grams is going to be 8 times 15 is what, 120? 8 times 5 is 48, 900, yeah, 120. So 8 grams would be 120 grains. If we had 2.5 grains and we wanted to convert to milligrams, well, here's an equivalency. 1 grain is 60 milligrams. So 2.5 grains, I'd take 2.5 and multiply by 60. That's what, 150. So if you memorize your ones on the left, if you're going from tablespoon to milliliter, you would multiply by 15. Milliliter to tablespoon, you divide by 15. If you're going from ounce to tablespoon, multiply by 2. Tablespoon back to ounce, you would divide by 2. So again, here's some practice problems. When you look at your slides, the answers will be in the notes at the bottom.